Rajan, I'm
Okay.
starting now.
Yes. So let's start. Good morning, everyone. Today we are starting our second technical session, and it is our pleasure to have with us Professor Anil K. Gupta, CSIR Bhatnagar Fellow. To chair this session, I invite Professor Chandrasekhar Sharma to start. Chandra, please, over to you.
Yes, thanks, Rajan. Good morning, everyone, for this second day of INYAS mid-year meeting. And we are starting the day with the technical session 2 on science and serendipity. Well, we have seen how the serendipity has played an important role in very, very important scientific discoveries, not only very recently, but from very long time. Uh, Still, few people consider serendipity is not a scientific approach. But then I think what we feel is that there is a science in the serendipity. And today's session will highlight some of those aspects. And we are really honored, and it's my indeed pleasure to formally introduce our keynote speakers of today, Professor Anil Kumar Gupta. Although he actually does not need any introduction, but for the sake of completion, I will just formally introduce him to the audience. So Professor Gupta is currently a visiting faculty at Indian Institute of Management, Ahmedabad, IIM Ahmedabad, after retiring from teaching from there, from the Center of Management in Agriculture, IIM Ahmedabad, for 36 years. He is also a distinguished visiting faculty at IIT Bombay and founder of Honeybee Network, trustee, GYAN, and National Innovation Foundation, NIF. Professor Gupta is currently a CSIR Bhatnagar Fellow, Fellow of World Academy of Art and Science, California, Fellow of NAAS, INSA, ACSIR Professor. He has been a member of National Innovation Council, chaired by advisor to the Prime Minister in 2009 to 2012, and has been the Executive Vice Chair of National Innovation Foundation from 2000 to 2018. He was awarded the Padma Shri in the year 2004 for his contributions to the management mission by the Government of India. He is seen as a pioneer in the field of grassroots innovations as reflected from his research and action interests. His research and action interests, to be very brief, expanding global, national, and local space for grassroots inventors and innovators, link creative and innovative ideas in informal and formal sector to ensure recognition, respect, and reward for them, protection of the intellectual property rights of small farmers, workers, creating knowledge networks for augmenting innovations and unfolding creative potentials of individuals, institutions, and societies through frugal, flexible, and friendly, empathetic, open innovations, particularly in the food systems and allied sectors. Ethical issues in conservation and prospecting of biodiversity, linking innovations, investments, and enterprise. Creating knowledge network at different levels for augmenting grassroots green innovations and technological innovations by youth to build a global value chain to get the creativity its due. Supports to Honeybee Network, including about 2 lakhs ideas, innovations, and examples of traditional knowledge from various parts of the country and rest of the world on farm and non-farm sustainable technologies, and more than 2 lakhs projects of students of engaging and related disciplines to techpedia.in and of susci.org. Support Open Data Initiative as evident from recent database developed at gyan.org and Techpedia, having 0.8 million abundant US patents for wider use by the farmers, inventors, animal or processing ventures, student, small entrepreneurs. Professor Gupta has been walking for a week or more every summer, autumn, and winter for over 3 decades, covered around 6,000 kilometers as a part of the Shodh Yatra journey on foot to celebrate creativity at the grassroots, to learn from grassroots teachers and share creativity of communities encountered so far, including the Shodh Yatra walking course for IIM Ahmedabad students in Himalaya region. With the help of Honeybee Network volunteers, Srishti, and Gyan volunteers, Professor Gupta is able to complete 45 Shodh Yatras open for all and about 20 for IIM Ahmedabad students. Well, just to be precise, I have no hesitation to say that Professor Anil Gupta is an institution in himself. I now invite Professor Gupta for his keynote address today, in which he will be talking about serendipity as a test of our wisdom, a scientific Shodhyatra. Over to you, Professor Gupta.
Thank you, Chandra. Thank you so much for a very generous introduction and obviously raising expectation that I will do some miracle today, which I will. Much depends upon, of course, how far we are ready to accept serendipity as a window into wisdom. See, what happens is that discoveries by chance actually are only metaphorically speaking by chance. There is obviously a search which makes or molds the mind to look for something. That something is there in the mind. What is that something we may not know? How will that happen? Also, we do not know. So, I will bring examples from the life of ordinary people who also make discoveries by chance, serendipitously, and there is something which we can learn from those processes. Because one of the questions that I would like to pose today and we need to reflect on is, how do we make our mind ready to make discoveries, make breakthroughs? Now, philosophically speaking, breakthroughs require a bit of a sync between inner and outer. So, what I think, what I reflect, how I feel is also linked to how I talk, how I present my work, how I deal with my knowledge and knowledge of others. Now, obviously, if my public posture is at great variance from my inner journey, inner quest, the chances of making breakthroughs are less because when I'm sleeping, I'm not sleeping with a dream of making discoveries, which happens sometimes even by chance in the dreams, as we all know about benzene ring. So it is not that benzene ring was discovered by chance. It was no. The scholar was looking for that structure for a long time and was readying his mind to discover that. Now, how can we discover that? So one of the processes that I'm suggesting is to look for or provide more space for spontaneity in life. Sahaj bhav. Spontaneity means that we don't always live a contrived life, always live in a contrived search, always expect that whatever course of action that I have chosen is the one that will discover results. I look for randomness, little bit of a randomness. Some journey, look at a creeper on a wall and it looks for cracks, minor cracks, micro cracks through which the tendril finds a space. And the mosaic that gets built, the way the creeper climbs on the wall and shows a pattern is a pattern actually not of its own making independently. It is an interaction between the cracks in the wall, micropores in the wall, the orifices in the wall, or some small uneven surface of the wall, the textural textural diversity of the wall, and the space it provides to the tendril to move along. So therefore, probably we also can look for diversity in our space, in our environment, in our mindscape. I used the term yesterday for a talk on memoryscape. Like landscape has uneven topography, memories also have uneven topography. So how do I create my mind? How do I prepare my mind for making discoveries by chance? Let me take you through some examples. So we were in 1988, I was having a workshop in Chitradurga in Karnataka of blacksmiths. There were some farmers, some artisans. And we were discussing about how do they discover new solutions to the problem. So one blacksmith, I narrated the story. He said, look, I had a wooden plow of acacia tree, desi babul. And this wooden plow, the shear had worn out. So I wanted to make a metallic shoe. A metallic shoe so that I don't have to abandon the handle, the entire shear of the plow. I would only put the metallic shoe on the worn out shear, and then my plow would be again valid for the next 20, 30 years. Now begins the material science research. He goes to a junkyard and start looking for materials that will have right torque, right weight, the right degree of tenacity to maintain its edge, the angular edge, the sharp edge. Now look at this. There is a matrix already created in the mind. That matrix is of weight, of torque, of density, and tenacity, so to say. And through that, different pieces of junk iron lying around have to pass through. Now look at this. He has prepared his mind. And then what does he discover? Can you imagine what would be that material? The material was the suspension of a truck. You know, the springs on which the tons of material in the truck suspends has the right property that he wanted. How did he make this discovery? He didn't know what are the material characteristics of the suspension. But he was trying to sense them by hearing the sound. He was knocking different materials and hearing the resonance. Now, you call it chance. The material was discovered by chance. He didn't know what he is looking for. But he knew the sound. He knew the instrument. He knew the kind of temper that the material should have. In fact, once another innovator in Junagadh had told me that, look, if you take a gear which has temper and a gear which does not have a temper and throw them both on a metallic sheet, hear the sound and you can make out which one has a temper. And I could. In other words, I can train my mind to be able to sense that temper, the resonance. In Bastar, when they fire the furnace to smelt iron ore into the iron through which they make their arrowheads, how do they figure out when the furnace should be broken? Those of you who come from material science would know that this is a very critical step, otherwise it will all become ash. So you need metal, low carbon metal incidentally. So how do they do that? They take a pipe, put it on the surface of the furnace, and the sound of the fire gives them the sense of temperature. Now this is weird, isn't it? How do you measure temperature by the sound of the fire? But they do that. They don't have a thermometer. So what I'm trying to say is that there is a great deal of new possibilities, new ways of thinking, new ways of discovering. There is a huge fertile ground around us lying in this country and around, and all the countries have this fertile ground. It's just that the scientists have not paid attention to the ground from which we can fertilize our own imagination. We have to fertilize our own imagination. So let me show you a few more examples, and then you will see that this is something that can be taken as a valid means of making discoveries, not just discoveries, I would say even breakthroughs. So a small digression, a small step about where does it come from? Because when I thought of Honeybee Network 30 years ago, a nameless, faceless person comes in contact with the network, gets an identity. A nameless, faceless person comes in contact with the network, gets an identity. And this identity I don't provide. Srishti, Gyan and Anab don't provide. All of you provide that. I must pay a tribute to the scholarship of this country, the scientific community of this country, that when we do validation and value addition, we need formal scientific help. And I can tell you, not one scientist has charged for his or her time in validating grassroots. That is a great tribute I want to pay. And your shoulders will have to carry this tradition forward, that after all, you can make your money from many other ventures. You have your own projects, you have your own consultancies, you have all avenues available in the world. But when it comes to validating the knowledge that a creative person from the grassroots level, from a farmer, an artisan, a mechanic, a laborer has discovered, why not then talk to and help them by contributing your might, your scientific knowledge in validating and value adding in those ideas. So let me give you an example of how discovery by chance took place in my life at different stages. So I was walking with my students. I also had a course Yatra. So I was walking in Himachal, Kangra, and I came across this tree. And suddenly this tree sort of was talking to me. So I went close to the tree. I said, "What happened?" The tree says, metaphorically speaking, "Look, I was not supposed to branch. I branched." Then the question rose in my mind, what do I do? There is a mistake that I have done. So I made it into a parallel stem. It's a real tree. I have not morphed it. Please understand. This is a real tree. What is this process called? Whereas I am talking to you, many cells in my body are going through mutation. Thankfully, these mutations are not cancerous. So I can continue to talk to you. This process of my body of repairing, rejecting, replacing, bypassing the cells and making me continue my conversation with you is what is called as autopoiesis. This tree taught me a new concept, a new model of innovation called as autopoietic model of innovation. Of innovation, which means self-correcting, self-design, self-organizing. Now, once Dr. Mushalkar was telling me that he came from Delhi to his lab in NCL. He was at that time GCSF. And he had a photograph of self-organizing gel on the cover page, and he showed it to a PhD student. And PhD said, "My God, I had also seen such a gel. Why didn't you tell me? We would have been on the cover page," Dr. Mushalkar said. Well, I thought it was odd. It was different. It didn't tally with what I was looking for. Now you understand. Even such a great scholar and his student could do a mistake of this kind. When he told me, I said, my God, this is a powerful metaphor of how do we make our mind ready? How do we mold our mind to make breakthroughs and not reject, by definition, things that don't follow the trend. And what is the trend? Don't mind my saying this, my dear friends. I'm going to say this. Some of you may not like it, but I'll say that. You know what? In our research papers, and it is true for PhDs, but also true for postdoc and many other scholars, 90%, maybe 95%, maybe 99% references are cited approvingly. We agree with everybody. How can it be possible? How is it possible that we agree with everybody? There will be some people whose ideas I intuitively feel are not right. Therefore, I will collect evidence, or at least I will generate hypotheses by which I will say there are other ways of looking at this data or this particular evidence. So it is not that we lack genius. We have enough of it. But what we lack is a peer group, and that's where INYAS' role becomes very important, a peer group which will provoke us to be able to question and make mind ready to look for odd observations, things that don't follow the trend, things that are different, things that are not in line. So let me show you another example. So in Champaran, we met Ram Tamari Devi. There were a lot of grain bin. They're very poor people. They can't make grain bin inside the hut because hut is very small. So they make grain bin outside the hut. And out of about 150 kilometers of walk in Champaran, Motihari, we started from where Gandhiji had gone. You remember during the struggle for freedom when the indigo workers were being exploited and wanted to protest against that. So this was one bin on which there was a beautiful artwork. So we asked her, why did you do that? She thought she had done a mistake. She said, what else could I have done? My God, excellence is the only choice. What a great value. A culture which makes excellence imperative and a sense of helplessness. Oh my God, I can't do a mediocre job. I'm sorry, I'm helpless. I can't do that. I just know this much. And then we told her that we have not seen such a beautiful artwork everywhere. She smiled and shied, felt shy, and was slightly embarrassed because she thought she was just an ordinary person. She was an ordinary person, but with an extraordinary spirit. Now, you could have walked through and left it out on its own course. Let me show you another discovery of this kind. There are several times in the show Yatra we find such opportunities to redefine our own, not only value system, but even the toolbox of concepts, of techniques, of methods by which we make sense of this complex world. So this was a tree under which terracotta horses were lying in Purulia. And we were walking through and just discovered this, and they were beautiful. And we asked the potter from the village, why did you keep such outstanding terracotta horses and elephant outside, under a tree? Somebody can break it, somebody can take it. They said, Professor, you've done a mistake. By the time they knew that I'm a professor, some people were calling me as Professor. I said, what mistake have I done? You haven't kept the most beautiful ones, they said. We have kept the best ones. Best ones. Why did you keep the best ones? So you see this small pathway. Yes, there was a Kacha Rasta. Our children go to school by walking on this pathway. When they go to the school in the morning, they should know what the current standard of the best our community can produce. They should do better. Can you imagine open source standards of excellence? Which management book have I read this in? No. Some of you do this. Some of you post your papers in the corridor. And that's a good practice. It creates heartburn, causes heartburn to some, jealousy to others, envy to others. But it's a good practice. When you break through, you publish a paper in Cell or in INYAS or Nature or wherever. I think it's a good thing to celebrate. Open source standards of excellence. Some labs do. Many labs don't do. That's up to them. But what I'm saying is that our society has discovered this principle in a drought-prone area of West Bengal and Purulia, a backwater, so to say, economic backwater. We call that as a backward region. Why backward region? Economically backward region. People who are poor in wealth are not poor in mind. Please understand that. My book in 16, Grassroots Innovation, had a subtitle, Mind on the Margin or Not Marginal Mind. Let me show you another example. We were walking in Anantnag in Kashmir, I think 2008-9. And we suddenly saw this wall. Now, what do you find on this wall? Spotless, isn't it? We were struck. We thought, say, it looks like a newly painted wall. We were curious, so we knocked at the door, said, can you come in? It was a house of a weaver. When we went inside, the house seemed to have a very old loom, old window, old kitchen with a folding door and so on. So we asked, look, your wall is impeccably clean. Did you paint it recently? Did you make it recently? Did you plaster it? He said, no. It is a 30-year-old house. 30-year-old house. Not a blemish. You know the walls of your lab in cities like Hyderabad, Bengaluru, wherever. You have black spots. So when the organic matter flows with the wind, fungus attacks, or smut, and then the black spots are formed. Now, there is no black spot here. So what is this surface? So we said, how did you do that? Sir, it is 30-year-old surface. 30-year-old surface. Unbelievable. I've never seen a wall like this, 30-year-old wall like this, in any city or anywhere. In our own campus, for that matter, any other. I visited so many labs around the world. How come? What did you do? Sir, we took the jute fiber, old jute bags, pounded them with the clay, and that made the surface antibiotic. Oh my God, we used titanium dioxide, nanomaterial, nanoparticles, and use them in the paint to make our clean room, our lab, in our surgical ward in the hospital as antimicrobial surfaces. And here is the technology by which a person has been able to successfully achieve a wall exposed to open air, snow, water, rain, whatever have you, and wind, and not allowing any surface, any organism of the kind that can burst into the black smut or rust, leaving a mark. Remarkable. Now, those of you who are interested in pursuing, those of you who come from material science, may like to look at literature, and you will find that jute seed, old jute seed, actually is used as a pesticide. And jute fiber has that property. But the clay and jute fiber together give this property, because you can, in fact, find fungus growing on jute fiber if it is lying in the moisture for too long. So it is not enough that jute fiber itself will have, but then jute fiber dried, pounded. So they pound the clay in it. If you have seen some monasteries, in Buddhist monasteries, the way they make these monasteries, some of you might have seen in Bhutan or in Ladakh, they pound it heavily for days and days and days and days. The wall gets built inch by inch, inch by inch. A huge process. So how did it happen? It happened when we didn't know that we will see this wall, did we? Let us be humble and honest enough that we had no clue what we were doing. We were just having our mind looking for oddity. That's it. Looking for oddity. Serendipity is a search for oddity. Something at variance from what is expected. How do I create a socket about something that I don't know? That's the beauty. That's what prepared mind does. That's where the difference between knowledge and wisdom is. This was wisdom. Another example for Purulia, Bhavi Mahato. She had a wall, had no durable in her house. In my talk way back in 2009, I have mentioned that she proved Maslow wrong. Maslow said there is a hierarchy of needs. You can achieve actualization, self-actualization only after you achieve lower order. Wrong, completely wrong. Sant Ravidas was a cobbler and became a saint. While mending shoes, Kabir was a weaver, became a saint. While weaving clothes, Mahatma became a great artist. While making a wall of a house, having no durables in her heart. We have many examples of this kind in our country. I will now show one more picture, and I will close with that and wrap up so that you can see where I'm coming from and where I want you to go with me. Look at this. Look at this. Look at this. Can you imagine which pair from this picture was taken? It is, don't mind my saying, I don't care whether people in power don't like it, but I should tell you because I have a responsibility to young minds to be able to appreciate that we can make such great blunders. This is a picture from the campaign called as Incredible India. So we are asking tourists to come to India and see what I call as shame of India, what this photographer thought was the beauty of India. A woman in a scorching summer carrying a pot of water on her head is beautiful. This picture is beautiful. What is the meaning? What is the aesthetics of science? Is there a relationship between aesthetics and science? There is. So long as we see this picture as a beauty, we lack samvedana. There's a beautiful word, samvedana. Sam means equal, vedana means pain. When I experience pain of someone else as intensely as that person feels it, it doesn't remain that person's pain, it becomes my pain. Samvedana, equal, same degree. सृजनशीलता का जन्म होता है जब संवेदना से, तो कुछ नई बात पैदा होती है. So serendipitous discoveries take place sometime out of pathos, sometime out of pain in our self. So Vincent van Gogh had a lot of pain in his life. And then MacLean's song, the Starry, Starry Night, brings out that pain so well. He said, save me from my sanity. He was considered as insane. But the notion of sanity had to be redefined. Will have to be redefined when the scholars, when the scientists will make discoveries in a manner that nobody expects. They will be called as crazy for a while, sure. But that's okay. Can we live with that disapproval of peers for a while? I think we will have to. So what I want to close it as is as a notion that science requires multiple approaches, systematic trials. There was Dhulabai in Modasa Taluka, now a small district in Gujarat. He, like many other farmers, millions of farmers, walked through their field off and on, just like that. They want to, that is, as you go through the lab and walk through your lab corridors and, see things going on, you feel comfortable when you are around the glassware, if you are in the lab, or petri dishes or whatever. Farmers feel comfortable when they are in the field. He saw a plant. Now, mind you, a field may have millions of plants. How could his eye notice one plant which had red flowers, which can be tur dal jisko bolte hain, red ki dal. It normally has yellow flowers. Yellow flowers, as some of you might know, attract pests. And for which then you have to use pesticide, which I don't like, chemical pesticide, though there are herbal pesticide also. But nevertheless, most farmers use chemical pesticide, and the residues of that pesticide in that dal comes to my stomach and causes all health problems. So I would wish that we follow the path of sustainability, but that apart. So this farmer observed one plant with the red flower. He tied a thread, some thread he picked up and tied it, and used to visit it every day then afterwards. That led to a variety. He called it Dula by Patel number one. It used to mature early. The pods are very sweet. and the flowers was red, so didn't have much pest attack. So didn't have much pest attack, therefore there was no need to apply pesticide. Discovery by chance? No. He was looking for something different. He didn't know what he was looking for. He didn't know that there will be a red flower. He thought there may be something different. There are farmers like that who have developed varieties which have been protected by PPVFRA in this country, have got presidential award. Richa variety by Rathore in Madhya Pradesh, in profusely bears pods from top to the bottom of the plant. Like that, there are many varieties which have been developed by farmers. HMT grows in 10 states. HMT variety of paddy by a famous farmer. Now, question is, if discoveries are made, can we accommodate serendipitous path as one of the many paths through which we might be ready to accept and accommodate observations at variance from our preconceived notion of what is valid. And once we change the notion of what is valid knowledge, what is expected knowledge, I think discoveries will start being made. So I stop here, friends, and will be very happy to answer the questions. I hope I have kept to the time, and I'm looking forward to surprises. I'm looking forward to make serendipitous discoveries today.
Thanks, Professor Gupta, for the wonderful talk, as usual. So I invite the questions from the members. Either you can raise your hand, or you can type in the chat box, or you can put in your WhatsApp group. We'll take from there.
No, yeah, go ahead, please. Go ahead.
Thank you, Professor Gupta. A very, very insightful talk. I really loved the part when you said that, minds on the margin are not marginalized minds. So my question to you is, to what extent, with your experience, which is so truly based in, you've given us Champaran, Bastar examples from your own life. So to what extent do you think that a predisposition towards serendipity, or to be able to make different kinds of observations, lies in the difficulties that you've had in your own life? Some people have it comparatively easier, and some people, a lot of examples that you've shown today, have had difficult times. Does that have any, what I'm trying to possibly ask is, do these difficulties more, as I say, people who can't listen, they can see better. People who can't speak, they listen much better. So this with serendipity,
Yes, your question makes a lot of sense to me, because now I'm going to mention something that many of you will not like. I believe in the concept of voluntary suffering. In our history, in our traditions, we call it Hatha Yoga. Self-flagellation. You punish yourself. Tap hota na, tapate hain. So there are many ways of tap. People do fasting, people go for abstinence, people live with very little means, different cultures. In every religion there is a concept of long-term fasting, isn't it? Every single religion has it.
Even in modern conventional households, we have this
Correct. Why do we do that? Because that might trigger in the mind thoughts about those who are less privileged, who are less provided for, who may go through that not as a choice but as a compulsion. And I think in science, if I want to make solutions possible, discoveries which are frugal, which are low cost, which are accessible and available and affordable by the poor people, then I need to. And I'm saying this is a value judgment. I'm passing my moral judgment. I'm saying need to, but it could be maybe, it could be desirable. But to my mind, it is necessary that we need to go through oscillations, cycles of hardship, voluntary suffering. So when I take my students to Himalaya for this course, they are assured of no comfort whatsoever. They have to sleep on the ground, they have to eat what people eat, they have to, if they take, most of them don't take bath, but if they have to, which I do, glacial water in Ladakh, then they have to take bath in glacial water, because that's the only water that's available there. And if leeches are there on their body, then that is it. I can't do anything about it. They have to let leeches be and find ways of keeping them away by salt and whatever have you. So they make discoveries. And one of them made a discovery, sir, this spray that I had, aerosol spray, is also able to remove leeches now. That was by chance. It happened. Struggle, voluntary struggle. When I said pathos, I didn't mean pathos only by suffering physically, but the pathos of not being able to solve the problem. That's uneasiness, isn't it? This is discomfort. You're suffering because you are not getting the answer to the problem that you've asked. And day in and day out, you can increase the intensity of your uneasiness to an extent that mind will now be open to look for solutions beyond what I am normally looking for. So I would say that creating discomfort to that level, that serendipity shows the way. I mean, it can, among the 1,000 observations lying in front of you, the one which is least likely to capture attention may get your attention if you were suffering from a great hunger for the solution. I think sometimes we get satisfied too early with too little. Sorry for saying this.
Thanks, Professor Gupta. So I take next question from Ramanathan. His question is, how does commercialization or capitalization look at and exploit these grassroots innovations? Also, how does institutionalized knowledge look upon these raw, unschooled innovations?
Ramanathan has also asked another question, so I will link all the three together. First of all, I don't like the concept of Jugaad. I will begin with the third one. Jugaad is a temporary solution. It's not bad. It can solve if earlier our cars used to have regulator and radiator water cooled. So if there was a leak, then somebody will put a soap there to plug the leak for a few kilometers you could drive. Now what is the problem with Jugaad? That it creates mindset which is satisfactory, which is happy with temporary solutions. Now, I know Dr. Lalji Singh, some of you might have met him, he was a dear friend, CCMB. When he was a young scientist, I'm talking about when CCMB was just evolving, it was under construction, the building was under construction, Dr. Bhargav was founder director. And he, coming from Cambridge, used to fabricate his own glassware. There was a glass blowing room at CCMB, maybe he's still there. And they would fabricate their instruments because the observations they were wanted to have were not possible with the instrument that you have. Now, how will breakthroughs happen if I'm going to constrain my imagination by the tools that I have? And I'm saying that let me not be constrained. So Jugaad creates a mindset where I just make do with what we have. Temporary solutions, fixing temporary solutions. And then no country can become truly smart, truly intelligent, truly prosperous by just following that. So that is one. Regarding the transition from mind to market, as Dr. Shekhar often says, first of all, we must remember that a lot of solutions each one of us has used for which we never paid. You have downloaded a lot of papers freely from the net without paying for them. So the notion that commercial market must always mediate a transaction between potential user of a solution and producer of a solution is a very limited understanding of how society works. I and you can download a paper and use for my research without paying for it, but a farmer should not get anything without paying for it. This is absurd. So we need to follow both approaches. DIY solution, do-it-yourself solution, open knowledge, open innovation, open sharing of my discoveries. By choice sometimes. I file a patent as a defensive patent that nobody else can monopolize, and then I can make it open source. We set up a fund in NIF many years ago when I used to be there, GTIAF, Grassroots Technological Innovation Acquisition Fund. First, we filed patent. More than 1,000 patents have been filed in the name of innovators, and some have been granted in US. In 2003, Srishti had succeeded in getting a patent granted for 3 innovators from India, none of whom was educated beyond 10th class. Now, in Makkah of innovation, industrial and engineering technology gets patent. That means the prior art of that country had not anticipated that knowledge. Otherwise, US Patent Office will not grant patent, isn't it? So they have proved that it is possible for the unschooled mind, as somebody said rightly, to produce discoveries which are extraordinary. Now the question is, if you and they join hands. So for example, we have a database of antiviral plants, and I'm looking for this kind of collaboration today. I hope some of you will say, we have BSL-3 and BSL-4 facility, send us those extracts and we will screen them. And I would very much wish that if you have, for COVID, we have various kinds of viruses, let us say. We didn't know about COVID. So we have, in our database, people have used plants for various kinds of viral infections. We will send you those extracts. Screen them. Who knows that some of those extracts are the ones that we are looking for? There is no solution at the moment. There is no medicine, isn't it? Supposing we find one. And how would we find them one? Maybe some new compound can be discovered from those plants. So I'm saying this kind of partnership is what is not happening enough. It is happening, but not enough, particularly among the young scientists. And I can tell you that if you make this discovery, you would be on the front page of New Scientist or Nature or somewhere. Because what happened to artemisinin? When Dr. Yu, CDRI was also working on the same plant. And China was also working on the same plant. They relentlessly pursued it and developed the malaria drug. We went on publishing reports. We published far more papers, in fact, to be honest with you. And we knew a great deal about chemistry of this plant. We didn't make the discovery. And time and again this happens. That Nobel Prize winners will cite our papers. That's a matter of great pride for me. But then, why not you? Why only being cited? So I think that degree of uneasiness is required, that degree of impatience is required. बेचैनी के बीज बोने भाई हमको अपने दिलों में, बेचैनी के बीज बोएंगे और श्रद्धा की खाद लगाएंगे और लगन का पानी देंगे तो कुछ ना कुछ तो नया पैदा होगा. ये तो मैं मानता हूँ. मेरे को, I'm sorry for speaking in Hindi for a while because that's my mother tongue and I studied in Hindi medium school. So I think in Hindi and then translate in English. That's the way my mind works. So I'm happy with this new policy which says that at least first few years should be in mother tongue because our hard disk is formatted in the mother tongue. And once it is formatted, I can store any language on it, any data on it. But the formatting should be in mother tongue. And I strongly believe in that. Having said that, any other question, please?
Yeah, thanks, Professor Gupta. One question from Niti from CDRI. How to encourage attitude of innovation or creativity at school and college levels?
We have just announced a competition called as Ignited Mind competition. Dr. APJ Abdul Kalam Ignited Mind Children Creative Innovation Competition. 15th September is the last date. ignitedmind@honeybee.org is the email address. And you know, the youngest child we gave an award was class 1. Can you believe it? Niti, class 1. What did he do? So, Chris Anant was his name, from Viludnagar near Madurai. His father sent us the conversation between him and his father. And that conversation inspired us so much. We said, this boy deserves the credit. So I'll tell you one boy and one girl example. So this boy was having shoes which made sound, you know. You have seen those shoes. When children walk, they make sound. Chun chun. So his father was doing vacuum cleaning. Chris Anant, 5-year-old, observed him doing that. He said, why do my shoes make sound? Father said, there's a whistle. He said, there's a whistle, then air must be going out because he knew how to blow the whistle. His father said, yes. Then air must be coming in. Father said, yes. Then why can't my shoes become vacuum cleaner? Can you imagine? This kid has observed, analyzed, abstracted, and applied all the 4 stages of making a discovery. He could do that at the age 5. So please don't tell me that we need to make our children discover. They are already making discoveries. The problem is that ambitious parents and teachers stereotype the search of children so much that the moment child makes something odd, something different, focus. The reply comes, the reprimand comes from the mother and the father. Focus. You will not get marks for thinking like this. Oh my God, children have become instruments in the ambitions, in the aspirational ladder of the parents, and would not be allowed to think freely and be able to become an artist, a musician, or a scientist of their own kind. They have to be scientists of the kind that their parents want, the kind of that that the teachers want. That is the unfortunate reality for our middle class families, where children are their rings are clipped, they're trimmed like a there was a garden, and I put this teacher took his disciples and gave them an assignment that make different gardens, landscape them, and I will choose the best one. So one of the disciples said, "Look at my garden, sir. I have made it beautiful for you." So it was beautiful, spick and span, and there was a tree in the middle. And he said, "Okay, now make me sit on your shoulder." So the disciple took the teacher on his shoulder. "Take me under the tree." He took it under the tree. He shook the branches, and the dry leaves fell on the ground. He said, "Now it is beautiful." This randomness made a manicured garden beautiful. Allow children to have little randomness in their life, spontaneity in life. That will be beautiful. But we train them, we clip their vision so much, the tunnel vision, focus, focus, focus. Yes, we need focus to achieve results. We need Arjun and we need Yudhishthira. Yudhishthira, when the test was taken and Dronacharya asked them to focus on the eye of the bird, Yudhishthira said, "I can see the whole earth, whole cosmos of which is earth is a part and this tree." He said, "Get lost, you will never be a good Arjun." Arjun said, "I see eye." We need both. We need children who will be able to focus, but we also need Yudhishthas who will be able to see the connections in the entire cosmos. The large context should be very much important. And we need to imbue in children a natural desire to discover what they want to be. They want to be Yudhishthira. They will be great ecologists. They might be a great reductionist scientist, maybe. And maybe somebody will have both the skills. So, Niti, I'm sorry for long answer, but I think I feel very pained when I see very intelligent, brilliant parents like you training their children to be so sharply focused that they feel that only way middle class children can aspire for good life is by good marks. Of course, marks are important. I got 40% marks in my English in higher secondary, and 60% marks, less than 60%, 58, 55% marks in drawing. Science and math, I was good. My division was 58%, second division. It took me so much effort through my BSc and MSc to compensate for that stigma. But it was possible. And I reached where I was supposed to be. But it took effort, surely, because my teacher wanted me to write what he told me to write. And I wanted to write originally. So I made more mistakes. So my marks were cut. But the price I paid for that was to be able to think originally. And that is, I think, something that people need to think about. Yes.
Thanks, Professor Gupta. So I will just take one more question because we are running short of time.
Yes.
And for that, Dr. Durva Sen Gupta, she said, serendipity is the search for oddity, as you said. This is GEM. But other than training to keep your eye open, is there more one can do?
Yes, I would say that if you can put down on a piece of paper the trend lines, so to say, the boundary conditions of our model. And this model is constraining my vision to the observations. So the outliers on my map of scatter plot of my observations. A long time ago when I was doing a regression, and many times to find out whether your model is biased, the residuals are plotted. And when residuals are plotted, if they are not random, that means there's a bias in the equation. So I would say that when you plot the observations and draw the trend line of your results, for a change, once in a while, ask yourself the question about the outlier, a value which is far away from the origin or far away from the trend line. What does it convey? And that, to me, is a very systematic way of looking for something which is quite at variance from the expected line. So what may happen is, it could be an environmental error. It could be an error because there was an experimental error, or there was some chance variation in that test tube or in that petri dish, or something happened. The density of the media was not right there, or something happened. Or it could be a mutation. It could be a variation which nature has introduced in my sample, and I should look for that. So I would say leave 10% of our time, if not more, for odd observations. And if we do that, my feeling is that we will start making discoveries which are beyond the trend line. The trend line is important because if you publish a paper, most journals would like to have observations which are consistent, surely. But we know those independent relationships are found in drugs. Same drug at a different dose has different impacts. So therefore, it is not impossible to find new ways of representing data, and looking for observations at variance from our assumed notion, might help us to discover. I'm a great believer in spontaneity. When your intuition says that, look at that observation, look at that. Don't stifle your intuitive voice. Intuition has a role to play in science. And great scientists always have had a strong intuition, a gut feeling, so to say. They don't know why. And women have more intuition than men. That's a subject we will discuss some other day. I teach that class in my course, in Cine course, and I have a whole theory of why women have more intuition, how their brain is wired in a manner that they're able to make intuitive remarks which we men are incapable of. We are inadequate instrument of nature, we lack that ability. And this is something that I'll be very happy to talk some other day with you all on this subject. Thank you so much. I can't hear. Your mic is muted. Mic.
Yeah, sorry. Thanks, Professor Gupta, for your enlightening talk and remarks. And INYAS would be very happy to listen you once again. So we will find another occasion to call you for more time. And I think within the given mandate of INYAS for science outreach, I see a lot of possibilities to join the Honeybee network and speak with INYAS. So I will definitely be in touch with you for looking this potential and to carry out this potential further. With this, I really thank Professor Gupta for your time and for joining us.
Send me the chats with the.
Sure.
There are many comments which I would not be able to reply now because of time.
Yes,
I
will share you those questions, and if you can answer, then we will share it with our members.
Yes, please.
Yeah. Thank you, Professor Gupta.
Thank you so much. Thank you so much.
Okay, I think that was an amazing talk, and let's start the other speakers in this session. First speaker in the session is my colleague, Dr. Gitanjali, and I mean, just in the interest of time, I just hand over to Gitanjali. I think Gitanjali, you are able to sort out the technical issue with your presentation. Are you able to share yours, or should we share from our side?
No, I think it is better if you share it. We don't waste more time in trying to get my presentation worked out.
Sure.
So just while this is being done, I'd like to just present a base for our technical session, because Dr. Gupta has already done a fantastic, perfect setting for us. Quite a lot of us have had questions over the years about think like, are some people better at creating the conditions for the coincidences or serendipity to arise and taking advantage of them when they do? But if that is so, then we ought to also be able to connect the dots of seemingly random events to improve our lives and improve the work that we are doing, indeed. So I think today's talk, the technical session that we planned with the 3 talks that I have, I'm hoping that my own slide will become visible very soon. We have tried to bring together speakers and themes to explain that serendipity is not about luck in the sense of simple randomness, as Professor Gupta was saying. It's about having this serendipitous mindset and seeing the links that others don't, combining these observations in unexpected and strategic ways, and learning how to detect the moments when apparently random or unconnected things merge to form new opportunities. So I said,
just to interrupt you, Gitanjali, your presentation is now there. You can start, and I will interrupt you after 13 minutes.
Okay, so I can see my slide now, I think. Just a sec.
Yeah.
No, I still don't. Yeah. Thank you so much, Shekhar. Can we go on to the next slide, please? I mean, this is just an introduction. I'm Gitanjali, and Shekhar is already. I'm a member of INYAS for the last 5 years.
Yeah, so Gitanjali, I'm changing the slides.
Thank you, Rajen. So the word serendipity itself, as some of you may or may not be aware, was coined in 1754 by the writer Walpole. And the strange thing is, he found it a very expressive word because he thought that he had once read a fairy tale about three princes of Serendip, these three guys who used to roam around everywhere, making surprising discoveries, solving things, making a fortune. Lucky blokes is what people thought they were. But Walpole felt that they were not really lucky blokes. They did something that was akin to Sherlock Holmes. They were not frivolous. They were men who had got the best formal education possible, and their father, the king, had realized very early that children cannot be made to learn just from books. And again, bringing us back to Professor Gupta's problem with ambitious parents. What he did was he sent them out traveling to new lands, and then these three princes, they were traveling everywhere, so they were the princes of Serendip. And all of their true learning actually happened by this out-of-the-box going out and doing. Similarly, next slide please, in science, this refers to the occurrence and development of beneficial events by mere chance, the act of finding something valuable when you were not looking for it. And I think that part is something that has played a huge role or a crucial role in sciences more than any other subject. Most of the world-changing revolutionary discoveries that you've seen in biology, medicine, have a serendipitous side to them, if not entirely serendipitous. Whether you think of the discovery of penicillin, heparin, X-rays, which I'll talk about today, gram staining, anesthetics, think of diabetes. It's equally true for most other areas of science, not just medicine and biology. The discovery of electric currents, the connection between electricity and magnetism, even the microwaves. All of these, and many more are sheerly out of, we may not know sheerly out of ignorance, but these are still serendipitous events. But today in my talk, by describing how some of these discoveries were made, I hope to demonstrate how the breakthroughs that seemed accidental often occurred only after years and years of work, scientific thought, observation, before and after the event as well. So these are the four things I'll talk about today, that you've got to have a strong fundamental knowledge of whatever subject you're working on. And of course, you've got to have that extra ingenuity, creative thinking, the openness to be able to see an outlier for what it is or not. And of course, a right attitude. Next slide, please. This is an example of how background knowledge had helped in serendipity. Mark Edman is a marine biologist and a very famous one right now. But in 1997, he was on his honeymoon and he had discovered an ancestral fish in Indonesia that was not known to have existed for 400 million years. He was at this fish market and his wife noticed this strange-looking fish being wheeled in by a cart, and he immediately recognized this fish as a coelacanth, and he excitedly photographed it, but then he moved on. See, as most of us do, we don't think immediately of that moment as the life-changing moment for our lives. He moved on because he doubted that they would actually have stumbled upon something, such a major discovery. But still, he had stopped and clicked a picture. That was because he had the background knowledge. He was an expert marine biologist. He knew that, this is a coelacanth, and he knew that these are rare species, and he knew, and they must have been found in Indonesia previously, is what he assumed. Unfortunately, they did not purchase or preserve it. And later, when he came back to Berkeley and discovered that he had made a huge discovery, he went back and spent 5 months in Indonesia, found the second coelacanth. And then there was this paper in Nature, and then the rest is history about it. The thing is, background knowledge is crucial. Don't assume that it will just come to you as a walking example. There's lots in the history of wheat, especially in plants and agriculture, the Bramley apple, even Mendel's P-cross experiments. A lot of us still believe that Mendel was a saint. He was basically just doing his little bits of P-crossing. He was a mathematician. He had
It's 11 hours.
And so he was just the right guy at the right time to ask the question of what the units are and how the dominant and recessive traits are working. The 3:1 is simple to us now because we've been reading it since kindergarten. But for him to come to that arrival, or come to that conclusion, was because of his background knowledge in mathematics and statistics that he had gained from a degree. Next slide, please. And this brings me to my hero, of course, Steve Jobs. This, you would say it's not a biology example, but it is. All of my work in the last 20 years, all of my science has been done on a Mac. And Steve Jobs is the father of this whole idea, and his life and his story and his success is the one thing that tells you that you don't have to be the first one to see something, but you've got to be the first one to see something different. And it is an example of creative thinking. Creativity is less about your own ideas and more about how you pursue those ideas. Steve Jobs audited a calligraphy class in his college. I do a lot of these. I take little classes here and there with college students, and it's quite interesting quite often the comments that students give you or your listeners give you. And in one of these calligraphy classes that he was taking for college students, he later credited the inspiration for Apple's beautiful typography coming out of this class that he had taken. In his 2005 Stanford lecture, he explained how he could never have connected the dots looking forward, but the connection was clear to him in retrospect, looking back 10 years later. So a lot of serendipity is indeed about looking back and being able to connect the dots in retrospect. The other famous example of creative thinking is Percy Spencer. Now, this guy was you all know, he was working with a company using microwaves, and he noticed that whenever he's working in this area, whenever he goes into his factory, the area completely begins to heat up, and he began to use that to make popcorn. And the rest is history about microwaves. Next slide, please. Accident or ingenuity. Quite often we believe that serendipity is about accidents or happy accidents. Yes, they are about accidents, but not just about accidents. William Keith Kellogg, I was telling this story. So I've been preparing for this talk for the last couple of weeks, and I've been giving one serendipity story to my children every night before we sleep. And I told them the Kellogg story because at our home, there's no life without cereal in the morning. But Will Keith Kellogg, we know that 200 years ago, this guy came about. He was working he was a research assistant on patients' diets in a hospital, and he was the one who made the mistake of leaving the dough outside one evening, and next day he comes and sees it as flaky. He didn't throw it. He decided to still roll and bake it, and the rest is history. We have cornflakes. But the thing is not about that accident or what he did next morning. The thing is, what we don't usually come hear about is Will Keith Kellogg's entrepreneurial ingenuity. He tinkered his recipe for wheat flakes. It was actually wheat flakes that he had made by accident. And ultimately, he was the one who settled on using corn in place of wheat as the main ingredient of the flakes. And therefore, he called them cornflakes. In 1906, he launched his own company. Even today, many young scientists have this brain block, including myself, when it comes to launching your own company. I mean, who's going to do all that? In 1906, Bill Kellogg launched his own company. He had a genius for marketing and business, not just the research and the science that he was doing. He was a pioneer in testing markets, sampling products, using multicolor print advertisements, slogans. He used a lot of interesting slogans that should be a story that you should be reading separately at some point in time, developing innovative marketing campaigns. So it's not just a happy accident. Serendipity is equally about the ingenuity in you. Next slide, please. And of course, you need to have an inquisitive mind. Willem Röntgen, he was trying to pass electrons through air. We all know that he saw across the room a screen and there was light formed when he was doing the experiment. And he thought that, wow, this can be, he called them X-rays at that time because he didn't know where they're coming from. But the name X-rays has stuck permanently. There are conflicting accounts of his story. But the issue is that from the beginning, Willem knew that this could be a turning point in medicine. And he was this picture that you see is the first picture of a human, a first photographic picture, X-ray picture of any human part. And it was his wife's hand. When he showed his wife this picture, she said, the poor girl, she said, I have seen my death. In fact, the discovery of X-rays was a turning point so sensational that in 1896, when it happened, in that year alone, there were 50 essays and 1,000 articles written about X-rays. Science dedicated 23 articles in that year alone to the issue. In fact, so much so that a lot of these articles, if you read them, they are about the kind of ways these X-rays are occult and paranormal activity, and they connected the other part, the other dimension to science. But of course, now we understand what these are indeed. Similarly, an inquisitive mind is what led Darwin to make the observations that he did on his voyage on the Beagle, and the triple rediscovery of Mendel in 1903, which began the century of the gene as we knew it. Hugo de Vries, he was just walking past the primroses one evening, and he saw these bigger ones. And then it was like what he says in his autobiography, it's like the culmination of all of my dreams come true. Till then, he was thinking that Darwin's mode of evolution, he had a question with it. He felt that evolution should not take these millions of years or thousands of years. Evolution can also happen overnight. Of course, he ascribed it to mutations, these large Oinothera lamarckiana flowers. But as we know now, these are chromosomal aberrations. But Hugo de Vries had it in his mind to look for that change while walking past a garden of primroses. He noticed the other ones, the ones that were even reproductively consistent. And so therefore, an inquisitive mind is another important thing that can help you. Next slide, please. Perseverance. And this brings me to a very important factor, perseverance. From an Indian point of view, the Bose-Einstein statistics is something all of us know about. Bose developed it, and Professor Satyendra Nath Bose actually developed it and recognized that a collection of indistinguishable particles can be distributed in unique ways. And it was an idea that was later adopted and even extended by Albert Einstein. And it therefore became a collaborative theory called the Bose-Einstein statistics. But how did it begin? Satyendra Nath Bose was presenting a lecture on the theory of radiation to some students at a university in Dhaka, I think. And he committed an error, which unexpectedly gave a prediction that agreed with the experiment. The error was a simple mistake. Anybody should have been able to recognize that this is an error. But Bose realized that it might not be a mistake after all. And for the first time, he took the position that the Maxwell-Boltzmann distribution would not be true for all microscopic particles at all scales. And so he wrote a little short article to be sent and published in the Philosophical magazine. What happened? Nobody's guess or everybody's guess. Rejected, of course. The referee's report was negative and the paper was completely sent back to him. Bose was undaunted, and this is what as scientists and young scientists we need to know. Bose remained undaunted and he sent the manuscript to Albert Einstein directly, and Albert Einstein read it, agreed with it. He personally translated Satyendra Nath Bose's paper from English to German. The paper came out together as their collaborative in 1924, and the rest is history. But then again, there could be other stories. Hemendra Kumar Prithviraj Gandhi, a very interesting story of a pioneering Indian phycologist and diatomist. To be true, I didn't know about it, but only in the last 2 weeks when I started putting on Twitter and my social media post that I'm going to be talking today about serendipity, a colleague shared this story of Hemendra Kumar Prithviraj Gandhi. He is a small college lecturer from Gujarat, and his experience with Indian reviewers, mostly competition between his work, his colleagues, and interpersonal other people's big positions, created a lot of negativity, but still he persevered. And that's the next slide. On the next slide, I'll show how he persevered. All right, so this slide basically tells us that success and interpersonal competition can have many more, far-reaching consequences and interconnected issues. And there have been huge monographs written on evolutionary perspectives on physical appearance and personality of people and morality in the context of where you're working, what you're doing, and the intersection of culture and learning styles, which lets you see how different people in different localities suffer from the same issue of interpersonal competition and overcome these. But even so, globally, I think these are very common issues, and we need to find ways of overcoming interpersonal competition to be able to do justice to science and advance science, essentially. In case of H.P. Gandhi, as we will see on the next slide, Gandhi's master's thesis itself, when he was an MSc student, at that time he had found 10 new species of diatoms, and he had described 21 varieties and 40 new forms of algae. He published scores of papers later in international journals over 40 years of his working life as a government college lecturer. But his experience in India is something that everybody must read about. I'm only giving 2 snippets from his document. His entire story, which I've read over the last couple of weeks, is extremely interesting. I think we should all read it. The title of his paper is My Work on Indian Freshwater Diatoms and My Experience with Indian Referees and Editors. And he says in conclusion, it may be suggested that Indian referees and editors should be more tolerant, unprejudiced, fair, open to correction, resilient, above all reproachful stand of favoritism, partiality, pushing in one's own faulty and manipulated papers for citations, hypocrisy, and other assumed expertise. So you see how interpersonal competition can make people really lose hope. Many of us do end up losing hope. But Gandhi's experience Gandhi's, own personal experiences are worth reading, and they make you want to be better people. I thank you, Karthik Balasubramanian, for sharing this with me. Next slide.
Last 1 minute, maybe, or two.
Okay, 2 minutes. I think this is my last part only. I'm anyway wanting to talk about missed opportunities in science. I'll give a few examples of how antibiotics, they were the mighty mouse of medicine since the discovery of penicillin through serendipity in 1928. And it seemed there were very few bacteria that couldn't be destroyed. But today, because of the rampant use, it's so bad right now that we have really missed the opportunity of antibiotics. And even when antibiotics are not warranted, parents are, giving them openly to their kids. And when the symptoms of the infection are abating, the patients are often throwing away these pills, allowing the bacteria that had not been killed off to mutate. And that's not a good thing. I won't give the example of the most expensive, immediately obsolete technology of iridium. Read up about it yourself. But many of you who are not millennial children would remember the Y2K story, how we were treated to an entire year of talking heads ranting on about doomsday scenarios. $100 billion, were wasted on trying to save aeroplanes from falling off the air on the morning of the turn of the century and the millennium. Nothing happened. In retrospect, we can only say, thank you, Bill Gates. Next slide, please. Yes, of course, this is one thing that I think all of us should be aware of. Shocking factoids based on half-baked interpretations of scientific data have been foisted on the public at an alarming rate during the past 7 months, particularly in COVID. Every joker around you who has nothing to do with data science or viral epidemics is now an expert with a couple of grants or a couple of papers under there. I don't want to see this as a missed opportunity. I know that each one of our listeners possibly knows one such person, but the worst part is that this is not the less privileged folks who resort to such shortcuts. Even the most famous of us all fail. You know the story of the very recent Lancet and WHO controversy of hydroxychloroquine, but 35 years ago, it was even worse with the spinster brewers. I'll not go into it. Look at it yourself. Harvard and Yale scientists making a sweeping decision about when women should get married based on some statistics they had done. We'll not go into that. And again, the thalidomide story. Thalidomide, everybody believed William McBride, and he became the greatest whistleblower, visionary, and so on. Even though his original thalidomide papers were not based on true observations, he was eventually proved right. Later again, 30 years later, he made the same mistake, and he was found guilty of scientific fraud, such a famous, known person. And he said the same thing in 1993, and it was shown that he had messed up, altered his data. Next slide, please. And I think that's my last slide. In my last slide, I want to end on a positive note. Chance favors the prepared mind. What are the ways in which you can cultivate innovation, serendipitous moments, and a mindset that is positive? First and foremost, please learn to switch off your brain. Go on to doing something mundane. Wash utensils. COVID is the right time to do it. Seek out new experiences like the three princes of Serendip. The king had sent his sons outside. Go out and travel. I mean, not now, but seek new experiences. You could take a new class. You could learn a new language, do some art. Do more, think less. The more you think, the more your brain will tell you that you're thinking wrong, and you will have doubts with yourself. Don't doubt yourself. And the last thing which somebody asked today, and Professor Gupta had said also, peer interaction. Listen to your environment. The peer environment is crucial. Ask your audience. I've been tweeting and getting a lot of interesting ideas from my own peers. You should do that too. If you're an entrepreneur, take the inputs from your customers. If you're a scientist, take the inputs from your students. If you're just about anybody, listen to your audience. Thank you very much. That was the last slide for me for science and serendipity. Signing off now.
Thanks, Gitanjali.
Okay.
So, as per the format, we will go for the question answer session in the last.
Later.
So now I request you to proceed further.
Okay, thank you so much. All right, so our next speaker is Upasana Ray. Upasana is a life member at the Vijnan Bharati. She's also an affiliate member at the Indian Mountaineering Foundation. This girl goes running and climbing all the time. She's a senior scientist, a virologist by profession at the CSIR Indian Institute of Chemical Biology, IICB, and she will show you today how virologists have together across the world worked on COVID and come up with some stories of serendipity that she would like to share with us.
Yeah, hi, and thank you so much for that excellent introduction of mine. So let me share my screen and tell me whether you can see. Can you see my screen?
No, not yet, Upasana.
Yeah. I hope you can see now, right?
Yes.
Yes.
Yes, Upasana.
Yeah. Okay.
Please make it in the slide mode.
So, yeah, I did that.
Now
I think
perfect.
it's going to take.
Perfect.
Yeah. Yeah, okay. Thank you so much. And Gitanjali, you have already given a pretty good introduction about serendipity and also the three princes of Serendip. So, yeah, so the title is here. And when Chandra asked me to prepare a presentation on this topic, I was like, what to present on this? Because there are so many examples in science and serendipity. So, we were going through a pandemic, and I thought that, okay, let me connect COVID 19 with serendipity, right? And but today I'm not going to give discrete examples of the discoveries made serendipitously. Rather, let's understand what serendipity is all about. Okay. So yeah, as already discussed, Walpole coined the term serendipity, and how did he coin it? He got influenced by a fairy tale, The Three Princes of Serendip, which was originally written. It's a Persian poem, originally written by Amir Khusro, and it was called as Hush Behish. In 1312, it was written, and this Persian poem was then translated by Elizabeth Jamison Hogis, and then it was named as the Three Princes of Serendip. Serendip, the term itself comes from Sri Lanka. Okay, so that's the Persian name of Sri Lanka. So Hodges discussed accidental discoveries and achievements of three princes of this fairy tale in this book. So once upon a time, there were three princes of Sri Lanka, and the king wanted them to take over the kingdom. So, but he made a clause that no, you cannot do it now. Rather, you have to go, leave the kingdom, and gain some life experiences, because these princes were very intelligent. So go ahead and gain some experiences through your intelligence. Come back, and then you inherit the kingdom.
Guru, Ram Ram.
So that's how the serendipity
अरे
was discovered.
अरे गुरु YouTube नहीं देख रहे हो
I'm
आप?
going to narrate one story from this fairy tale. This is about a camel.
ले थोड़ा दिन लेने दो.
Tell this story very short. So let's describe the camel first.
अरे शाम को
Picture from the internet. So sorry for that. So this camel didn't have a leg. Didn't have a tooth in the mandible. You can see I've shown it here. And this camel was carrying two baskets on both the sides. One had honey and one had butter. Okay. So how did the princess come to know about this camel? So these three princes, they actually used their intelligence and their intuitions that there is a camel who walked over the desert. And in fact, let me tell you, when they presented this data with people, people thought that these princes had stolen the camel, and they were put in jail. Later, they were released, of course, because they helped the owner of the camel to get back the camel. So how and now like serendipity, it was a discovery, it was made accidentally, but these princes used their intelligence and knowledge to deduce to the conclusion. So that was the story. And so what we can say about serendipity is that it's a way to make discoveries. There are four important terms, very, very important in this regard. That is, the discoveries are made by accident, yes, but that accident is triggered by sagacity, very important, intelligent choices, experience, and knowledge. So it's not only accident, right? So what do we have to do? We have to ignite our minds. And it's a very pretty book and very, very influential book, best-selling one, written by Dr. Abdul Kalam. What he has said here, so he spoke about vision, dream, and commitment, right? There were very nice quotes put forward by Dr. Kalam. I'm going to talk about three of them. The first one is that there is a need to change the mindset of the people. That is very, very important. Everything is your mind, right? Then thinking is the most important thing, and then comes the hard work. And another very important thing is something has to be at stake. So you have to have a crisis. So when there is a crisis, human mind has enormous power to get ignited, and then the working capacity gets enhanced manifold. So now if I link science to serendipity, what is science and what is serendipity? Serendipity helps only if science is conducted in a certain way. So science is an art, right? So discoveries or inventions come when you have certain important, very, very important qualities in you. So you have to have curiosity. That is most important. You have to have curiosity, the urge to learn. You have to ask questions, and those questions have to be logical questions. So you have to think. Then you have to be very, 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 very honest about the results you get. You have to discard your bias. So whether it's positive, whether it's negative, you have to support what you get. Then you have to take risk. You should be courageous. And it's very important to fail. And you have to fail more, and you have to come back, try more. So perseverance. And you have to retain that perseverance. So all this curiosity, asking questions, honesty, courage, and perseverance, they lead to discovery or invention, finally. Now, let me connect science to COVID-19. So we all know by now that last year in the month of December, in the city of Wuhan in China, there was an outbreak of coronavirus. Yes?
Upasna, you have a minute.
Sorry?
You have 1 minute remaining. You can take 2. It's okay.
Yeah, so I'll be done. So there was an outbreak in Wuhan. So it was a coronavirus, SARS-CoV-2, a novel coronavirus, COVID-19 as we call it as. This coronavirus slowly spread worldwide. There was a global crisis, and WHO declared it as a pandemic this year. Now, you can see here that eventually this infection spread worldwide, and this is a very recent data from WHO's website. As of 30th July, these many people have already been reported to be positive from India itself, and over 34,000 people succumbed. Right? So what has COVID-19 led to? It has led to a severe crisis in every sector of life. So chance was everywhere. We didn't understand about the virus. We didn't know what the virus was. Diagnostics, no drugs. There was no treatment. So this crisis led to an aggressive R&D activities, both in industry as well as academia. So it led to discoveries and inventions about basic biology of this virus, evolution of this virus. There were many drugs and vaccine candidates which underwent preclinical stages, and some of them also got into advanced trials. And this is pretty amazing. We don't see this kind of thing happening so often and so fast, right? So in next 2 slides, in short, I'll just tell you what we faced in academia as scientists and also by the students. Because of this COVID-19 crisis, academic institutes went into crisis. So we started hunting for chance, serendipity, right? So the chance. So we lost our time. We were at lockdown. The wet lab experiments halted. Students' future were at risk. Fund crunch was there. So taken together, the performance altogether was at stake. So this created anxiety, and that was the trigger factor. So there was an internal urge to progress and survive. So how we survived, it was through collaborations, and also we were at lockdown, so we went in silico. Very, very important. You have to come out of your comfort zone. So in silico approaches, collaboration, social networking, very, very important. Then we did drug search, designing of diagnostics, and biology of the virus. So taken together, it was a technological upgradation of the students and the scientists. So this is my last slide. I'll just tell you what did we do in our lab. So in the backdrop, I have shown, this is a very pretty picture here. It's a picture from our rim to rim, backcountry trek in Grand Canyon. So this was the last 2 hours of our trip. We were about to reach the North Rim, and the weather went very, 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 very bad. And it's very bad when it's a bad weather in Grand Canyon. Okay, it's dangerous. The Colorado River was gushing, and we were very tense. So you see, what we see in this bad weather is a pretty rainbow. So we cheered up. Okay, and this rainbow was touching the sky to the ground. And COVID-19 crisis turned out similar to us. We were trained in one way. We were wet lab virologists or biologists, very poor in computational biology, but we knew some bioinformatics. So I asked my students that you cannot shut the lab. Even if you are at home, you are work from home, you have to work. So, and I have very good students, so they picked up. So they started understanding the mutations in using bioinformatic platforms. So another dimension opened up in my lab. They started drug repurposing for that. They started training themselves. Now 2 of my students are pretty well trained in doing virtual screening. We are still learning MD simulation. So we made collaborations. We had publications. Funding came in. And we learned a lot, although we were in crisis. So I end here with this quote of mine, that crisis creates chance, serendipity. Chance is the key to serendipity, and you have to accept this crisis, ignite your mind, and become flexible. Very important. Discoveries will then follow serendipitously. And thank you so much.
Thank you, Upasana. This is a wonderful point to end your talk on, about and especially about how chance favors the prepared mind again, how your students have been able to take. We've heard stories of papers that you've been able to publish recently, and I totally appreciate that. And I think all of us would, virologists across the world, have to come together to work together in the fight against COVID. And that is what I think is going to take us ahead. In this thing of time, I'd like to now invite to speak our third and last speaker of today's session. This is Dr. Chandrasekhar Sharma, is the chairperson also of the Indian National Young Academy of Science. Chandrasekhar is an associate professor at the Department of Chemical Engineering, the IIT Hyderabad, and he is also, very interestingly, the owner of a startup company called Restyro Technologies Limited. So, Shekhar, you will talk to us about your experiences as well as about serendipity in science today. Please start your time starts now. Okay. Do you have your slides? Great.
Yeah, thanks. So you can see my slides, right?
Yes, we can see your slides, Shekhar.
Okay. Yeah, thank you. So, after the wonderful talk of Professor Anil Gupta and followed by the scientific discoveries by serendipity as briefed by Gitanjali and Upasana, connecting the serendipity to the COVID-19, the present pandemic, I will take some example of serendipity from my own lab, and then we'll conclude the session and we'll take the question answer. So, if you see Carbon Lab, which starts from creative and advanced research based on the nanomaterials, So the philosophy of the Carbon Lab at IIT Hyderabad is from this quote of Ken Stott, I always leave room for serendipity and chance. So I will take few examples from my own lab, direct recycling of polystyrene, waste or thermocol, electrospun nanofibers based feminine hydrogen projects, and candle soot carbon for powering the electric vehicles. Let me see the first example of how the serendipity can play an important role in uh, in useful applications, societal applications like direct recycling of the waste materials. So we see the polystyrene everywhere around us in terms of packaging material for electronic items, for the food products, and also since it's an insulating material, it can be also used as a flexible insulating material in the energy saving buildings. And with that, we see these kind of scenes around us too often. Since there is no mechanism to recycle this polystyrene or thermocol, no even recycler can accept these waste from your community. Well, we have another example of agriculture waste, which is citrus peel. Orange is one of the most common example of the citrus fruits. And we see that after consuming the fruit, there is almost 50% of the fruit in terms of its peel, which is wasted. And of course, there are certain uses of this orange peel, like in drying or in the food essence or even the beauty products. But there is no scientific use or scientific supply chain of this waste material. So now the thing is, can we come up with these two things which have no connectivity with each other? And that's how we went for this example in our lab. And this is coming from the childhood experiment. If you remember, most of you, if not all, we used to have this orange peel for two uses. One, to squeeze it into the eyes for irritation, and second is we used to press upon this orange peel onto our palm, press the scale, and used to make fibers out of it. And initially, when my student approached me with this, because we are working with a micron or nano-sized fibers from long time, so when she approached me with this, that yes, we are getting these fibers, we were quite excited to look into more scientifically about it. And initially, in fact, we thought that these are the fibers coming from the orange peel. And in fact, we even we filed the provisional patent based on the natural fibers. However, when we looked into these fibers more carefully, we realized that there is something more to it. So just to give an example, when did we realize that this is not the orange peel fibers? So when we continuously started using this polystyrene based scale in our lab, we found that after some use, it gets corroded. And that is where we started looking into it more carefully. So if you see the orange peel, which is around 20 to 25 gram, if you extract the juice out of it, you get around 5 ml of primary extract. And if you allow this extract to settle down, it forms three layers, as shown here: top layer, then middle layer, and the bottom layer. And we get the fibers from that. I will show you how to do that. But what we realize is that when this scale is getting corroded, it means this polystyrene, which is the material for this scale, this is being dissolved. And what we realize that basically this orange peel, the solvents present in the orange peel, they are dissolving the polystyrene, and from there we are drawing the fibers. So they are no more as the orange peel fibers, but they are the polystyrene fibers. And this is, let me see if I am able to, yes. So this is the experiment which we used to do, and that has led to this new process of recycling the polystyrene. So you simply squeeze the orange peel on your palm, press it against the scale, and draw the fibers. And if you continuously do it for quite a bit of time, let's say 5 minutes or 10 minutes, you get to see the nice fabric out of it. And you can make simply long fabric of around 15 to 20 centimeters. And when you see these fibers, they are very nice aligned fibers of tens of microns. So, well, what is so special about this fabric? So when we check this fabric, what we found that if you put a water drop on this fabric, it does not get absorbed. It remains on the surface while it absorbs the oil completely. What does it mean? It means that wherever there is an oil-water mixture, you can use this fabric to separate the oil from the water. And that has a great application in many ways in terms of oil-water spills remediation. We also tested further because that's an important point. If we want to use it for the oil spills remediation, that even in the buoyancy conditions, when you are turbulent conditions, so unlike the cotton, which also absorbs the oil equally well, but unlike the cotton, even after absorbency, it remains floated on the surface. And this is something very important because if you want to use it for the oil spills remediation, it is you need to take this out after absorption, and that is where it remains floated and you can take it easily out. So with this simple process, which we used to do in the childhood, which we have never realized that what we are doing, we have developed an innovative process to directly recycle the polystyrene using another waste material, citrus fruits peel. And this recycled polystyrene fabric can be used in the kitchen towels, textile, to the large scale applications of oil spills remediation. And remember, this material itself, even now, it's a polystyrene, which is an insulating material. So it can be also used as a flexible insulator for the building materials. And based on that, we started a company in IIT Hyderabad, Re-Styro Technologies Private Limited. We filed many patents. Well, the story does not end there. So if you see this extract, as I mentioned, it forms three layers. Top layer, which can be used for polystyrene recycling, and also the full solution. And also this full solution can be used for another very important and novel thing, which is called print transfer. And especially for the women scientists here, you can see this print transfer, which might be very useful for you in terms of nail art. So you simply take any print material which you want, any material which you want to print or transfer on the surface, and you put it and squeeze the orange peel on top of it like this, and gently press it after squeezing this orange peel. So once you squeeze, gently press it and then just take it out and remove that paper material, and that's how you get it printed on your nails. Well, unlike the nail art things which are there in the market, which use the very thick organic materials which are harmful, this is simple and it's quite stable. You can even rub and put into water; it remains there for few days at least. Now, the beauty of this process is that it is not just only on the nails. You can transfer this any print material on any surface. We have tried it on different materials, be it glass, wood, mica, or papers, textile, your cloth, and even on the human skin. So for tattooing purpose also, it works equally well. This is on the textile. This is on the skin, and you can see nice same process, and you can do the printing on your skin. So these are the different substrates on which we have tried, and this is how this was further. We got the project from the DST, and we made the pilot scale machine, and now we are basically looking for its commercialization. Second example I want to share is electrospin nanofibers for feminine hygiene application, and I acknowledge my students, basically MTech student and the summer interns only. So if you see the sanitary pads, feminine hygiene product, they use the super absorbent polymers into its absorbent core. The reason for this material to use in the absorbent core is to have the higher absorbency, because the fibers inside the absorbent core, they cannot absorb so much of fluid. But the problem with these superabsorbent polymers is that they are coming from the petroleum-based products and they are non-degradable. And in fact, apart from the environmental issues, there are also health issues related with the prolonged use of the sanitary pads, including the toxic shock syndrome, and there are unconfirmed reports of cervical cancer as well. So now the question for us is, can we simply tune or can we simply achieve the similar absorbency without going with this super absorbent polymer? And we did with the nanofibers. So if you see the commercial sanitary pads, they are made of the few tens of microns of cellulose fibers. We simply change them to the nanofibers. And when we do that, we realize, and of course we did the test into different conditions of absorbency, including the absorbency under load in the different mediums. I do not want to go into the details of that, but just want to show you one representative graphs. that the cellulose acetate-based nanofibers, which if they are used in the absorbent core, they show much higher absorbency at any given point of time as compared to any other commercial sanitary pad which is available in the market. We have tested for different conditions all the sanitary pads of different companies. As we want to use it for sanitary pads, so the load conditions are also important, and even in the load conditions we have seen that it works better. So now the serendipity here is when we came across this nanofibers, we thought, okay, let's use the SAP, superabsorbent polymer, in the nanofibers. Maybe we can achieve further higher so that we can approach towards the diapers. But that didn't work. In fact, it worked opposite. So when we put the SAP, superabsorbent polymers, in the nanofibers, it works opposite because it does not, it is basically the nanofiber size is not allowing the SAP to swell. So it works in other way. So that is how what you expect is not something what you get. We did further residue tests so that there is no leakage in these nanofibers, matrix, and all that. And finally, with this, without even the SAPs, using the nanofibers simply, we can reduce the health-related risk and also solve the environmental issues related to these products. This is how we have made the prototype, and we filed multiple patents. Last year, we were granted the Chinese patent, and last week we have been granted the UK patent as well on this. Again, this was highlighted by a lot of international media, and including the Elsevier. They issued a press release on that. And again, we are looking for further commercialization or technology transfer in this regard. Third example I will take from the lab is candle soot. We all know candle soot, when we burn the candle, we get some carbon black material. And in fact, in our ancient time, or even in many, the generation before us, they used to have this candle soot in our eyes, but we never realized that what it is made of. In fact, there was an article in Science in 2012 about this candle soot, but that article was more focused on the hydrophobicity. So if you deposit the candle soot on any surface, it is extremely hydrophobic. It repels the water like anything. However, when we look into this candle soot from our point of view, when we looked into it as a carbon material, and we never realized that this carbon material, because we were working on the carbon materials for the lithium-ion battery electrode materials. So when we realized that can it be used there also, and when we use this material into the lithium-ion electrode battery, what we found, of course, the structure is very important. It's not just simple 30 to 40 nanometer particles, and in fact, in that way, it is one of the most simplest way ever reported for producing the carbon nanoparticles. You simply burn the candle and you are producing the carbon nanoparticles, as simple as it is. But apart from its size, what is more important here is this connectivity between the particles, what we call is fractal-like connectivity. And that is where it plays a very important role, which we never realized before we used it in the electrode materials. So unlike the electrode materials, now if you see the carbon materials, just to very brief, in the lithium-ion batteries, which we are using in our in our smartphones, laptops, everywhere in the electronic gadget items, there carbon is used as electrode material. However, the same lithium-ion battery, if we want to use it for the electric vehicles, where the current requirement is very high, this carbon material is never used because of the structural problems, of course. But this candle soot carbon material is not suitable for the electronic gadget items. Very, very unlikely than the regular carbon materials. And that is because of its unique structure and unique morphology. This candle soot carbon is rather more useful for the electric vehicle applications. And as you see this at 5C and 10C, which means at a higher current rate, the efficiency is higher. So if you compare this performance of this candle soot carbon material for the lithium-ion batteries for the electric vehicles, that is where it is found more suitable and comparable to the commercial materials like lithium titanate. Again, well, Elsevier has covered this article and they have issued a press release. And again, I think after that, there is a lot of research started from the candle soot, and I can see now a lot of new uses of the candle soot coming in the scientific journals. With this, I would like to summarize all these examples in just one quote from Akira Suzuki. The concept of serendipity often crops up in the research. Serendipity is a faculty or phenomena of finding valuable or agreeable things that were not being sought. I believe that all researchers can be serendipitous. With this, I acknowledge my group and the funding agency. Thank you.
Thank you so much, Shekhar. That was a very insightful talk, and the best part that I like about it is that you have given true examples from your own work. So all of us together in this session, the three of us have been able to therefore, I think, do justice to the overall idea of serendipity with examples from biology, chemistry, from all walks of life, as well as from our own research. And with this, we bring this session to a close, and we hope that we have illustrated how serendipity works and how you can train your serendipity muscle and use it to turn the unexpected into opportunity. I now request our listeners on a Teams app within INYAS, as well as listeners from outside on YouTube, to please type out your questions, because we have a short session on interactive discussion on the theme with the three speakers. When you're putting your question, please make sure to make it clear whom you want the question to, unless you want it for all three of the speakers, and we will try to address your questions and have a discussion now. So,
Gitanjali, Mukesh is waiting in the lobby. Mukesh Kumar.
I understand.
Mukesh Kumar wants to ask the question.
Please, Mukesh, please feel free to ask.
Thank you very much, Gitanjali. Chandra, it's a very nice talk. So I have a technical question. So did you observe any variation in the size of this nanoparticle if you change the distance from the flame to the substrate?
Yes. Yeah, very good question. Yes, definitely. So when we collect the particles in between of the flame or from top of the flame, it makes a lot of difference. And the reason is, when we collect in between of the flame, there is still a lot of unburnt wax, and that wax creates the impurities in the material. So the suggestion, and in fact we have reported also, we should collect the we should collect the candle soot from the tip of the flame, where the temperature is also highest, around 1400 degrees Celsius, and your material carbon is almost pure there.
Okay, thank you very much. Very nice talk. Thank you.
Gitanjali, we have few questions already in the chat box.
Yes, there is a question from Ram. V. Ramanathan asks, thank you for the nice presentation on serendipity. I wish to highlight an inherent contradiction. On one hand, there is a constant refrain to ignite the mind and tread the path less taken. But when one does that and sticks their neck out in a different domain, say in data science, as mentioned in the talk here, why is he or she mocked at and seen with disdain as a newfound expert? All right. I think that question was aimed at myself, and therefore I'm taking the liberty to answer Ram on that question. I welcome the other two speakers. If you want to come in and say something also, please feel free to. In my view, it is extremely important, as Upasana has shown with her example as a virologist. She came forward, she has worked on viruses previously, but she was able to bring in new tools and new expertise, I should say, like bioinformatics and computational biology into her work, but she had the background fundamental knowledge of virology. Similarly, a lot of my colleagues have been able to use plant sciences or the knowledge of plant phytochemistry to be able to see how phytochemicals have in the past helped overcome viral diseases. And that too comes in as a background fundamental knowledge, basic knowledge in science, which has been used against the epidemic. But these are two stories, or these are few stories which are positive. There are many other stories which are not. And that is what I was trying to bring in. And I think you got my point already. Anybody else who wants to say something?
Oh, I think you nicely explained. And so next question is from Sriparna, Gitanjali. Maybe I will read it.
Please.
Upasana, can you please tell any classical example of serendipity discovery worldwide during COVID-19?
Serendipity discovery worldwide. Well, COVID-19 itself is a very, very new, virus altogether. Serendipity, if I think that way, yeah. So when I say COVID-19, it's basically SARS-CoV-2. So before SARS-CoV-2, we had an outbreak of SARS-CoV-1 or SARS-CoV, right? So some of the structural similarities that we have seen with SARS-CoV and SARS-CoV-2 had led to the major discoveries about SARS-CoV, how it binds, which receptors it binds to, and how the interaction happens. And this led to quicker insight into the molecular interaction, I would say. So, like that, in different aspects, biological aspects of SARS-CoV-2 biology and evolution, I think in everything related to SARS-CoV-2, if we relate back to MERS and SARS outbreak, we can derive some of the other serendipitous discoveries. So, in every there is a relation.
Thanks, Upasana. But let me correct. This question was from Rajneesh. Sheparna has just pasted on the chat box.
Yeah, there can be a bucket full of examples, but I just made one.
Next question is from Mudrika. Thank you for nice presentation on serendipity. I wish to highlight an inherent contradiction. On one hand, there is a constant refrain to ignite the mind and trade the path not taken by others.
Sorry, I did not ask the question. Shekhar, that is the question that was asked by Ram. It has already been responded to. That is done, yes. Ram also has a comment to make though. All right. Please.
Yes, Ram.
Can you hear me?
Yes, we can hear.
Yeah, I was unable. Anyway, thanks for a good presentation. I just had a serendipitous, perhaps, moment, because when this all those linguist buffs here, the word serendipity was traced to serendip, and Upasana said that it is from the Sri Lanka. Actually, in Sanskrit, the older name of Sri Lanka is Swarnadvipa. So
Okay.
Swarnadvipa becomes Sarandip, becomes Serendip, and Serendipity. Thank you.
Yeah, thank you for that. That information I didn't have.
Are these all the questions? Do we have any more? Shekhar, can you see some on the YouTube chat box? I didn't see any earlier. Nothing on YouTube.
There is a question from Chirashri. Let me read it. What do you think are the reasons for limited number of breakthroughs from our country in spite of a lot of research fundings and other opportunities? Do you think our education system damps the intrinsic curiosity?
Well, I think all three of us should be able to answer that. But my direct answer is absolutely not. The difference sheerly lies in the sheer numbers of India. I think if you've not heard Shahid Jamil's talk, and he's given it quite a few times in universities and public platforms, he makes a very clear case of the repeated question people tend to ask: why, despite our large numbers, why do more Indians not get the Nobel Prize? It's a very similar question that everybody immediately tends to ask, and you put. The first thing you want to do is say that the Indian education system must be having a problem. That's not true at all. With the huge iceberg that India is, with the huge sheer numbers that India has, I think in order for us to reach a certain point where we would have more people sheerly out of density, you need to spend more time, give it more time. And I think that is what the government has been doing already, and efforts are being made already that we try to teach and educate illiterate children at every level of society, and it has to begin from there and go on to the end where more and more people would be able to make more and more discoveries. I think the large number of Indian scientists are already making very interesting and very good Indian serendipitous discoveries as well as non-serendipitous discoveries, but it's our ignorance, surely your ignorance that you don't see those stories. What the stories that you see are the ones in social media. The ones that you see more in social media are the ones you're following. The people you're following are more in the West. So it's a rounded circle. Anybody else wants to take that on?
I'll just say one thing, that I'm in the same page with you, Gitanjali, and but then I also think that in a country like ours, where we still have a lot of poverty, right? We cannot afford to think. All of you cannot think absolutely, independently and just go on hunting for new things. You have to follow trend. You have to follow a trend. So discoveries will take time. We are discovering, but we have to follow a trend also. We cannot afford that the Western world can.
But what about the last? I mean, another question from that. What about the education system damping the intrinsic curiosity?
Yeah, so education system, I think, so there is a very, written set down rules and what we follow. So the way we have been trained from nursery to class 12, the same way we have been getting trained year after year after year, with changes happening very slowly, right? So, yeah, so there, I think that we should bring in some changes, and we have already heard about it, that there are changes being proposed by the government in the education system right this year. So I don't know how it's going to influence. In future, there can be pros and cons into it, but it's a good try. So we are trying.
I think it's less about the national education policy and the educational system. I think it's more about what Professor Gupta said, ambitious parents. As ambitious parents, we want our children to be the toppers in class. We want them to do homework first. Right now, online classes are going on. We want our kids' homework to be uploaded first. We want to compare with other kids what they've done. And in this system, we are dragging them down like nobody's business. And if only we could just stop ourselves from being the ambitious parents we are, from forcing our kids. My son is 8 years old. He has a classmate whose father insists that every time the child has been asked to say what is her favorite thing, she says, I want to be an IAS officer. This is an 8-year-old child. Why are you? And the father is often participating in the classes, talking to teachers and saying, my child is studying for the UPSC. Can't you just leave her be? I mean, why are we forcing our losses and our failures onto our children? That is the problem with the Indian mindset. That is not with our education policy. It's right here, is what I think. Okay, that's all.
Yes, I think I agree with that. Rather than education system, I think we as a parents, we need to change our mindset, and we should allow the kids to have the creativity rather than just focusing on the marks.
Like the king of Swarnadeep. I'll call it Swarnadeep, not Serendip anymore. Now, Ram, to the point. Can't do it.
We have one problem though, so I don't know, I'm not answering, but I'm again questioning. So, say you give absolute freedom to your child. Okay, that's very good. I put an example in front of you after class 12. That child only starts, keeps on imagining things and creating very nice things, but doesn't do very good with respect to his or her score in class. So what next? Is it not a question in our country? What next? At least in West Bengal, I can say everyone is taught right in the childhood. You have to be a doctor, you have to be an engineer, you have to be a professor, right? So that's how we grow up. And we are not able to sustain ourselves in that competition. So competition is bad, but competition exists in our country. To exist ourselves, we have to sustain ourselves here, right? So that's why I said although it's good and it is ideal, we cannot afford to allow absolute freedom. So that freedom is not there.
There again, we go by what Professor Gupta said. You're absolutely right, Upasana. Professor Gupta said Yudhishthir is one end of the spectrum and Arjun is the other end of the spectrum. Dono ka bala nahi hai. So I think that is the... Shekhar, how much time do we have to continue this discussion? Do you think we should should I give the vote of thanks, or do you think we can continue?
Yes. 3 minutes we have.
Okay, do we have one last question? Time for maybe a last question?
Yes.
Okay. Can you? I don't see a question. Shekhar, do you see it? Maybe I'm not. The chat is not
No, I
up.
think yes, we can wrap up the session. You can wrap up.
Okay, with that, thank you once again to all of our listeners in INYAS and all of our listeners out there on YouTube. I do hope that you may see serendipity as a force that you can grasp, shape, and own, and as well as that, take home the idea of cultivating serendipity to increase innovation, influence, and opportunity in every aspect of your own lives, particularly if you're a scientist. With this, of course, I'd like to thank the session coordinator, Dr. Chandrasekhar Sharma, INYAS chair also, as well as all the speakers, Upasana, Shekhar, me, myself, and the core committee members of INYAS, and all the members who have been working very hard to make this media meeting and these technical sessions a success. It's been brilliantly live streamed on YouTube. I especially take the opportunity to thank every one of our listeners who have tuned in on a Sunday. I know what it is and how difficult it is to participate in this interaction. Thank you.
Yeah. Before we, we can put off the stream now, right? So before we
so much,
end the
Gitanjali.
session,
Thank
we have
you,
an
everyone.
important announcement. So